Good day to all of you. Today we shall discuss on POS, product of sums. So using this, if any Boolean function is given, so that is product of sums form or POS form, in which max terms are used. So on this topic we shall discuss today. So if we take a two variable Boolean function, then let x, y be the inputs. So these two inputs can have four combinations. Then four possible max terms will be there. So max terms are represented by capital letter M. So this is M0, M1, M2, M3. So how many max terms are here? 4. So for any two variable Boolean function, there can be four possible max terms. So for two inputs, possible combinations of inputs are 0, 0, 0, 1, 1, 0, 1, 1. Then how to write these four max terms? When x, y both are 0, 0. So that is called as M0. It is written as x ORed with y. This is a sum term. This is written using these input conditions. If x is 0, that is written as x only. If y is 0, that is written as y only. And it is a sum term here. So max term M0 means for two variables it is x plus y. We'll read like this. So but plus means here logical ORing. Then M1 max term 1 means that is for input conditions x equal to 0, y equal to 1. So x equal to 0 means x as it is, it should be written. Y equal to 1 means it should be written y dash in between plus sign. So max term M2 means input conditions are 1, 0. So x is 1, y is 0. X is 1 means x dash is written. Y is 0 means y is written in between plus sign. So sum term M2 is a sum term. Similarly, the last max term for two variable system here M3. In that x, y both inputs will be 1 and 1. So if x is 1, y is 1. So x is 1 means x dash, y is 1 means y dash in between this logical OR sign. So for any two input variable digital system, there can be four possible max terms starting from M0 to M3. They are as follows: M0 equal to x plus y because both x and y inputs are 0, 0. M1 is x plus y dash because x is 0, y is 1. M2 means x dash plus y, that is x is 1, y is 0. M3 means x dash plus y dash. Here both x and y are 1 and 1. Okay, so this is for two variable digital system. With this we shall move on to next three variable Boolean function or digital system. Okay, next in three variable Boolean function or digital system, there will be three inputs. Let the inputs be x, y, z. Okay, for three variables there will be 8 possible combinations, right, starting from 0, 0, 0 to 1, 1, 1, right. So the first combination is 0, 0, 0, next 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the different possible combinations for the inputs. So for three variable system there will be 8 possible max terms. For a three variable system there will be 8 possible max terms. They are named as M0, M1, M2, M3, M4, M5, M6, M7. So 0 to 7. 2 raised to 3 means 8. So max terms vary from 0 to 7. M0 to M7, right? So M0 means that is with respect to when all x, y, z are 0, 0, 0. Hence x is written as x, y is 0 hence as y, z is 0 hence as z. All are 0 hence x, y, z as it is they are written. In between we put plus sign. This is a sum term. Max term means it is a sum term. So m naught means x plus y plus z. We'll read like this. Plus here it is logical OR operation. So x ORed with y ORed with z, or x logically ORed with y or logically ORed with z. So instead of reading every time, we'll read this as x plus y plus z, and this is called sum term and it is m naught. So m1 means x is 0, y is 0, z is 1. Hence x as it is written, x is 0, y is 0, hence y as it is, z is 1, that is written as z dash in between plus sign. Then m2. So 0, 1, 0. X is 0 means x as it is, y is 1, that is here. So y dash, z is 0 means z as it is in between plus sign. Next m3, 0, 1, 1. So x as it is, this is y dash, this is z dash. So x plus y dash plus z dash. So 1, 0, 0 means this is x dash, this is y, this is z in between plus sign. m5 means 1, 0, 1. So 1 means x dash here. This y is 0 means y as it is. Z is 1 means z dash in between plus sign. So it is x dash plus y plus z dash, that is m5. So 1, 1, 0 means m6. So x is 1, x dash, y is 1. So y dash, z is 0 means z as it is in between plus sign. So 1, 1, 1 means that is m7. For that sum term is, so x is 1 means x dash, y is 1 means y dash, z is 1 means z dash. So with plus sign. So here the max terms are from m0 to m7 for 3 variable digital logic or Boolean function. So m0 is x plus y plus z, m1 is x plus y plus z dash, m2 is x plus y dash plus z, m3 is x plus y dash plus z dash, m4 is x dash plus y plus z, m5 is x dash plus y plus z dash, m6 is x dash plus y dash plus z, m7 is x dash plus y dash plus z dash. So that is all about for a 3 variable digital logic or Boolean function. The possible max terms from m0 to m7. These are the sum terms, or they are called as max terms. Okay. So with this understanding, next we shall move on to 4 variable Boolean function or digital system. So in 4 variable digital system or Boolean functions, there will be 4 input variables. So let the inputs be w, x, y, z. So here we are taking as w, x, y, z, but in the problem if they give a, b, c, d, those only we'll have to take. Anyway, there are 4 input variables. Here we are taking as w, x, y, z. So here for 4 variable system, the possible minterms are from m0 to m15. How? So this is a 4 variable system, means 2 raised to 4 max terms will be there. 2 raised to 4 means it is 16. So 0 to 15 will have to take. So max terms do vary from capital letter m0 to m1, m2 and so on till m15. So m0 to m15 for 16 max terms, possible max terms in a system of 4 input variables. So which are those we shall consider? First, for the inputs we will have to write all possible input combinations starting from 0 to 15. This is 0 using 4 bits of binary. This is 1 using 4 bits of binary. This is decimal 2 using 4 bits of binary it is written. So this way, starting from 0 to 15 using 4 bits input combinations will write. Okay. So When w, x, y, z are all 0, w is 0, x is 0, y is 0, z is 0, then w, x, y, z, they are written as it is in between plus sign, because we have to obtain m naught, that is max term. It will be a sum term. So here we are using plus sign, which means logical ORing it is. But we read as w plus x plus y plus z. This is m naught. Similarly, m1 means 0, 0, 0, 1 is the condition of inputs. Because w is 0, w as it is, x is 0, x as it is, y is 0, y as it is. But z is 1, z dash in between plus sign. So w plus x plus y plus z dash forms m1, that is max term 1. Then 0, 0, 1, 0 if input condition is there. So w is 0 means w, x is 0, so x, y is 1, so y dash, z is 0, so z in between plus sign. So w plus x plus y dash plus z forms m2. Next 0, 0, 1, 1 means w is 0, so w, x is 0, so x, but y is 1, y dash, z is 1, z dash. W plus x plus y dash plus z dash forms m3, right? 0, 1, 0, 0. So w is 0, w. X is 1, x dash. Y is 0, y. Z is 0, z in between plus sign. Hence w plus x dash plus y plus z forms max term m4. Similarly 0, 1, 0, 1. If input conditions are there, w is 0, so w, x is 1, x dash, y is 0, y, z is 1, z dash in between plus sign. Hence this sum term w plus x dash plus y plus z dash indicates max term 5. Next 0, 1, 1, 0. W is 0, so w, x is 1, x dash, y is 1, y dash, z is 0, so z. Hence w plus x dash plus y dash plus z represents max term m6. 0, 1, so w is 0, w, x, y, z are all 1, so x dash, y dash, z dash in between plus sign, which gives the sum term, that is w plus x dash plus y dash plus z dash is called as max term 7. Then 1, 0, so w is 1, x, y, z are all 0, so this w equal to 1, w dash, the remaining are taken as x, y, z. So w dash plus x plus y plus z represents max term m8. Next 1, 0, 0, 1. So here w is 1, w dash, x is 0, x, y is 0, y, but z is 1, z dash. So in between plus sign. So this term is w dash plus x plus y plus z dash, that is called as max term 9. Then 1, 0, 1, 0. W is 1, so w dash, x is 0, x, y is 1, y dash, z is 0, z. So hence w dash plus x plus y dash plus z represents m10, max term 10. Next 1, 0, 1, 1. W is 1, w dash, x is 0, x, y is 1, y dash, z is 1, z dash. Hence w dash plus x plus y dash plus z dash represents max term 11. 1, 1, 0, 0. So w is 1, w dash, x is 1, x dash, y is 0, y, z is 0, z. Hence w dash plus x dash plus y plus z represents max term 12. So m12. Next 1, 1, 0, 1. So w is 1, w dash, x is 1, x dash, y is 0, y, z is 1, z dash in between plus sign. This sum term w dash plus x dash plus y plus z dash forms max term 13. 1, 1, 1, 0. So w is 1, w dash, x is 1, x dash, y is 1, y dash, z is 0, z in between plus sign. This sum term w dash plus x dash plus y dash plus z represents max term 14. So all w x y z are 1 here, hence w dash x dash y dash z dash are taken in between plus sign. This sum term w dash plus x dash plus y dash plus z dash forms m15. So hence here max term do vary from m0 to m15. Totally there are 16 max terms in 4 variable system. Okay. So in 2 variable system, 2 raised to 2, 4 max terms will be there. 0 to 3, m0 to m3. In 3 variable system, 2 raised to 3, 8 max terms will be there. 0 to 7, that is capital letter m0 to m7. In 4 variable system, there will be 2 raised to 4 max terms will be there. That is 16 max terms. 0 to 15, that is from capital letter m0 to m15. So this is all regarding what is max term and how many max terms will be there in different number of variables, Boolean function or digital system, and how to write them. Okay. Next, certain queries will solve now. Small queries, but small queries which are needed to solve bigger problems. So if you take m0, this is max term in a 2 variable system. So x, y if you take as inputs, what is m0 in 2 variable system? m0 means in 2 variable system both are 0, 0. So if you take x, y as inputs, then m0 is input condition is 0, 0. So x and y as it is, they should be taken. So x and y as they are taken. Max term means it will be a sum term, and hence this forms the m0 in 2 variable system. Similarly, in a 3 variable system, if you take inputs as x, y, z, so m0 there it is, the input conditions are 0, 0. Then x, y, z must be written as it is because they are 0. In between put plus sign, and this forms m0 in 3 variable system. Okay. Then for 4 variable system, so m0 for 4 variable system, if you take, let the input variables be w, x, y, z. m0 means all will be 0. Hence all are w, x, y, z, all are taken as it is in between plus sign, and this forms m0 in 4 variable system. Can we write the max term 3, that is m3 in a 2 variable system? Yes. Can we write m4? Means here m means here onwards it is max term only. So can we write max term 4, m4 in 2 variable system? No. Because possible max terms for 2 variable systems are 2 raised to 2, 4, 0 to 3, m0 to m3. Hence m4 we cannot write for 2 variable system. Can we write m15 for 3 variable system? No, because possible max terms for 3 variable system are 2 raised to 3, that is 0 to 7. 2 raised to 3 means 8, 0 to 7. So capital letter m0 to m7 we can have, m15 we cannot write in 3 variable system. So can we write m16 in 4 variable system? m16? No. 2 raised to 4 means 16. So in 4 variable system, 2 raised to 4 equal to 16 max terms will be there. 16 means 0 to 15, that is capital letter m0 to m15, not m16. So m16 we cannot write using 4 variables. Okay. So we shall solve some more queries. Max term 3. So in 2 variable system, if you write this 3, it is written as 1, 1. So if we take input variables as x, y, then because they are 1, 1, so they will be written as x dash, y dash. So x dash plus y dash represents max term M3 in 2 variable system. So for 3 variables if you consider, that is x, y, z, so then this 3 is written as 0, 1, 1. So x is 0 here, so it will be written as it is. Y is y dash because it is 1, z is z dash because it is 1, in between plus sign. This indicates max term 3 for a 3 variable system. So for 4 variables, if you take w, x, y, z, they are the input variables taken. So if you write 3 with 4 bits, it will be 0, 0, 1, 1. So then w is 0 means w as it is, x is 0, x as it is, y is 1, y dash, z is 1, z dash. So in between plus sign. So for 4 variable system, this 3 is written as 0, 0, 1, 1. So if 4 input variables are w, x, y, z, w is 0, it will be w as it is, x is 0, x as it is, y is 1, y dash, z is 1, z dash, in between plus sign. So that is how whatever subscript is given, that must be expressed in terms of those many bits. In 2 variable system with 2 bits, in 3 variable system with 3 bits, in 4 variable system with 4 bits. This must be expressed. Then in terms of input variables, these will be written here for the max term. Okay. So this much basic understanding is needed before going to solving Boolean functions given in the form of POS, product of sums form. So next part of the topic is expressing Boolean function in POS, product of sums form. Right? So here this truth table is given. These are the inputs. There are 3 inputs, x, y, z. So 3 variable Boolean function we are considering. So this is the output f. Then here we write max terms, and max terms means which sum term. So in this truth table, so for x, y, z 3 variables, the possible combinations 0, 0, 0, 0, 0, 1 to all 1, 1 means 0 to 7. Totally 8 possible combinations of inputs are listed. That is first step in writing truth table. So that is what is there in the given truth table here. Next, output f, how it is varying they have given. So in truth table form, output is given here. So for 0, 0, 0 input condition, it is 1. So when x, y, z are 0, 0, 1, it is 0. So for 2 it is 1, 3 it is 0, 4 it is 0, 5 it is 1, 0, 1 condition of inputs means it is 5. So for that the output f is 0. Then for this it is, this is 1, 1, 0 condition of x, y, z, it is 1. When all the inputs are 1, the output is 0. So this is how output f is varying. This column is showing output f, how it varies according to inputs. Now to express this function in terms of max terms, m, we have to consider only where it is 0. So f is 0 for input condition 0, 0, 1. So this 0, 0, 1 means it is decimal 1. So capital letter M subscript 1 means max term 1 it is. So for max term 1, the sum term is x plus y plus z dash, because x is 0, y is 0, z is 1. X is 0, y is 0, z is 1. 1 means dash we have to take. Then where again f is 0 here. This is for M3. 0, 1, 1 means 3. So M3. So x0 means x as it is, y1 means y dash, z1 means z dash. So m3 sum term is written here. Again f is 0 here. So this is 1 0 0 means 4 m4. So that is x dash y z. So x is 1, y is 0, z is 0. Hence x dash plus y plus z is taken here. Then here also f is 0. 1 0 1 means 5 m5. So x is 1, x dash, y is 0 as it is, z is 1, z dash. So x dash plus y plus z dash is written, that is m5. Then again f is 0 here when all the inputs are 1. So x dash plus y dash plus z dash, that is m7. Now to express this Boolean function f of 3 variables, we should consider only 0 to express in terms of POS. So only those max terms where f is 0, that we have to consider. Product of these sums. So x plus y plus z dash. So x plus y dash plus z dash, x dash plus y plus z, x dash plus y plus z dash, x dash plus y dash plus z dash. So this is the function of 3 variables x, y, z that is given in the truth table. So it is expressed in terms of product of sums. Sums means max terms. Hence to express in terms of product of sums the given Boolean function, how it is varying according to inputs, we should consider max terms only for zeros condition of the output, and those sum terms or max terms are taken here, they are written with AND operation, means it is a product. This is a product of sums form of given Boolean equation. So this can also be written as f of xyz is equal to product. This is symbol, product of max terms. So we may write this or may not write. So anyway, product means this will be max terms only. So which is the max term here? m1, then m3, m4, m5, m7. So m is common here, 1, 3, 4, 5, 7. So we may write form either in this form or in this form. Okay. So that is what is expressing Boolean function in POS form, in product of sums form. Right. So next we shall solve a simplification problem which is given in POS form. Right. So example 1 is simplify the POS Boolean expression f of x by z is equal to this product of max terms. This is product symbol, this is max terms symbol. So in bracket 1, 3, 4, 5, 7 means the Boolean expression is given in the form of product of sums. This we have to simplify using kmap. So this is just now what we derived from the given truth table. So truth table for f was given, from that we have derived this. So the problem may be given in the form of truth table or directly in the form of this, or in terms of x plus y plus z, like that in detail in terms of sum terms, product of sums terms. Solution. So this is an expression having 3 variables. Input variables are 3. Hence in the kmap 2 raised to 3, 8 squares will be there. So 1, 2, 3, 4, 5, 6, 7, 8. They are drawn here. Then out of 3 variables, x is written here, yz is written here. X may be 0 or 1. That combinations are written here. For yz, possible combinations are 0, 0, 0, 1, 1, 0, 1, 1. So next, whichever max terms are present here, in respective place, we must fill 0. So this is a max term m0 place, m1, m2, m3, m4, m5, m6, m7. So m0 max term, m0 is not present, 0 is not there. So don't fill 0. 1 is there. So this is m1 max term place. So it is there. Hence fill 0. Then 2 is not there. 3 is there. hence fill 0 in that place. 4 is there, 5 is there, so max term 4, max term 5 place, fill 0, 0 because they are there in the expression. Max term 6, it is not there, so don't fill. So max term 7 place, max term 7 is there, so fill 0. This is how filling is done. After that, grouping must be done. So as to cover all zeros, minimum number of groups we have to take. A single group of octet is not possible because all 8 are not 0. Then quad is possible. These form quad, a group of 4 zeros which are adjacent. Why? Because on this line, if you take a fold, these 2 zeros fall on this. Next, on this line, if you take a fold, those fall here. Hence all the 4 come in one square. So these form a quad, one group of 4 zeros. So this is first group. So next, with this one group, 4 zeros are covered. Now we have to cover this. This cannot be made with anybody octet here. This cannot be made quad also. But this can be made pair with this. So these two are adjacent. Why? On this line, if you take a fold, this falls on this. Hence, both come in one square. They form a pair. Right? This is second group. Now grouping must be stopped because all zeros are covered. Next, we have to write row wise, column wise what are common for every group. So for this group, if you consider these 4 zeros, they come in these 2 rows. Row wise x is 0, x is 1 here, nothing is common, leave that. Then these 4 zeros are covered in these 2 columns. Here 0, 1, 1, 1. This 1 is common, that corresponds to z, and hence we have to write z dash because z is 1. Next, second group. This is a pair. There are 2 members. Both the members come in this row where x is 1, hence x dash. So row wise x is 1, that is common for both in the second group, hence x dash. Or these 2 members in the second group, they fall in these 2 columns. Here 0, 0, 0, 1. This 0 is common, that is with respect to y. Hence, as it is y, because y is 0, that is common. So x dash plus y. So x dash is row wise common in second group, y is column wise common, plus term here. We are solving with max terms, right? With these two, we will write the final expression. So simplified expression is f of x, y, z is equal to this one x dash plus y and this one z dash. Or we may write other way. Both are one and the same. So the solution is f of x, y, z is equal to in bracket x dash OR with y bracket complete. That is logically ended with z dash. That completes first problem. Then example 2. Simplify the given POS Boolean expression using kmap. F of x, y, z is equal to this product of max terms. So which are max terms? Here 1, 3, 4, 5, 7. Same as previous. Plus 1 don't care condition, 6 it is having. Okay. So solution. So now 3 variables means 2 raised to 3, 8 squares will have to draw in the kmap. Then whichever max terms are there, in those places zeros are filled here. Plus 6. So 0, 1, 2, 3, 4, 5. This is 6th place. So there don't care condition is there. We put cross. So filling is over. Next grouping must be done. So octet is not possible. So next we are trying for quad. So this is quad of adjacent 4 zeros. So this we shall make as one group. So another one is when don't care condition is there, it must be used as per the need for simplification. Now it should be treated as 0 for simplifying with max terms. Right? So this is treated as 0. If this is treated as 0, this 1, 2, 3, 4 form one group. Why? On this line, if you take a fold, these two fall on these two. Next, again on this line, if you take a fold, all come in one square. So this forms a group of 4 members. It's a quad, that is second group. Now in first group, row wise, in two rows they are covered, these 4 members, nothing is common, leave that. Column wise, these 4 members come in these 2 columns. Here 0 1, here it is 1 1. So this 1 1 belongs to Z, hence Z dash is common, right? So that is what is in first group. Row wise nothing is common, leaving that. What is common? Column wise is written. Next in second group, 4 members all come in same row. X is 1, hence X dash. Then they are covered in all 4 columns. So column wise 0 0 0 1 1 1 1 0, nothing is common, just leave that. So these two form the final solution, this one and this one. So what is here? Row wise common plus column wise common. So that is in second group, only row wise is there, nothing is common column wise, hence only one term here. So this is actually sum term. So this is another one with respect to first group. There row wise nothing is common, only column wise. So this is also sum term. Product of sum term means this term and this term we must write. So X dash is written here. So this is 1 and the second one is Z dash, right? So the final solution is X dash and Z dash, or X dash Z dash. That is the solution of this problem. Okay, that completes the discussion of POS, product of sums form. In that discussion about Maxterms, then expressing a Boolean function in product of sums forms. After that, solving 2 problems on simplification of given Boolean expressions which are given in the form of product of sums form. I hope you understood. Thank you.